In this previous question number 4, we have probably calculated the value of v, which is actually equal to 15, and then acceleration is equal to v over a, and that thing is equal to 15 is the speed, time is 20, so acceleration is 0.75 meters per second square. So now we will start the fifth question of this exercise. Particle P moves in a straight line. The velocity v meters per second at the time t second is given by v is equal to 2t plus 1 for time 0 to 5, then v is equal to 36 minus t square for the time 5 to 7, and v is equal to 2t minus 27, for which the time is 7 till 130.5. Sketch the velocity time graph from 0 to 13.5 and find the acceleration of that instant when t is equal to 6, and find the total distance traveled by the particle p in the interval from 0 to 13.5 seconds. So these are the three parts of this question number 5 of this exercise. Since the graph is split into three parts, the first part is from 0 to 5 seconds, and it is a straight line because 2t plus 1 is a linear equation. So if we have to draw the graph of this, let's say it is origin from 0 to 5 seconds, the first part, the y-intercept is 1, and it is going up till this part for 0 to 5 seconds, and this graph is 2t plus 1. This is the velocity of this graph. Then from 5 to 7, it is 16 minus t square, which is a quadratic equation. And we know that the coefficient of t square is negative. So it is a minima shape there, maxima shape there. So this is the graph like this. So it is the graph from 5. Here it is 6 because 16 minus t square equal to 0. Then t square is equal to 16. So 36. Or t is equal to plus minus 6. So this value will be 6. And then the graph is from 7 up till here. The graph is of this sketch 36 minus t square. And then from 7 till 13.5, it is the graph of 2t minus 27, which is again a positive slope. And here it becomes 13.5, and this is the time in seconds for this graph of this question. Then it is split up into three parts. So the first part is a straight line, second part is a curve, and third part is also a straight line. Then in the next part, they are asking find the value of acceleration when t is equal to 6. We know that t is equal to 6 lies between 5 to 7, and that equation is 36 minus t square. So acceleration is equal to dv by dt, that is equal to 0 minus 2t, or minus 2 into t value is 6 there. So it is minus 12 meter per second square is the value of that acceleration there. In the third part, the total distance traveled by that particle from 0 to 13.5 seconds. So let's say this is A1, this graph is A2, this graph is A3, and this graph is A4. So we are going to calculate the total area of this as A1 plus A2 plus A3 plus A4. Or we can use the integration for this part. So this value will be equal to x is equal to 0 to 5 2t plus 1 dt, that is A1. Then A2 there, which is from 5 to 6, 36 minus t square dt, from 5 to 6. Then from 6 to 7, because this graph is below x-axis, so we change the limits from 7 to 6. Because we have to give the positive answer for this. And again, the equation is same there. That is 36 minus t square dt plus the last part, which is the integration from 7 till 13.5 of this curve, which is equal to 2t minus 27 dt. Even you can use the trapezium rule and the right angle triangle for this calculation, but we are going to do this part by the calculus. So this is one way of their solution there. So this will become equal to 2t square over 2 plus t from 0 to 5 plus, for this integration, it would be 36t minus t cube over 3, and the limits are 5 to 6. Then this curve is there, that is again 36 minus t cube over 3, and the limits are from 7 to 6. And for the last part, it is 2t square over 2 minus 27t, and the limits are 7 to 13 point. So first, these are the upper limits, and this is what the lower limit, and when you put all these limits into this equation, then our final answer would be equal to this answer will be 84.25 meter is the total distance traveled by that particle, which is split up into the three parts with the velocities and different values of the time are there. So in this, we have to be very vigilant about the straight line and the curve, and the curve is maxima, and these two straight lines are there. So this is after putting the limits, just in the last part from 6 to 7, we will take the limit reverse 7 to 6, so that our answer should always be positive in that sense.